Hello, everybody. My name is Scott Courtier. I'll be presenting today with our very special guest, Mr. Jay Hughes from Omron. Let's go ahead and get started. The agenda for today is, again, my name is Scott Courtier, Senior Technical Sales Consultant for InduSoft. I will be talking about a little bit about InduSoft Web Studio communications, just a quick overview as Jay is going to present most of this webinar. Talk a little bit about driver worksheets and talk about tag integration and a little bit on OPC as well, just some of the different ways that we can communicate with different technologies within InduSoft Web Studio. Talk a little bit about troubleshooting. Now I'm going to talk about troubleshooting just in general InduSoft applications, while Jay will talk specifically a little bit about troubleshooting Omron type applications. So then I'll talk a bit about our training videos and webinars, and then I will hand it over to Jay and let him present away. So first thing I want to talk about is just general communication within InduSoft Web Studio. This is a graphic out of the help document that comes with InduSoft Web Studio. You can see here on the left, the tags database is tied into really everything within the product. It's kind of the core piece of the product, where the tags or variables, if you will, communicate or get the values, the properties, and other information from various sources within the product. It could be from the graphical screen. Let's say it's a bar graph or a slider on the screen, communicates to the tag. It could be a database. It could be OPC. It could even be a PLC driver. And what you can see here is that the tags database gets its information from any of these sources, and or all of these sources, I should say. So the next slide, I'm going to present this diagram in a slightly different way. And with InduSoft Web Studio tag database kind of being at the core of this diagram, you can see that we can get our information from over 240 different drivers that we have for PLCs, motion control devices, temperature controllers, you name it, a lot of different things. We have over 240 direct built-in drivers for many different devices. We can also talk as an OPC client to lots of different devices. Also get information from the web, and then in addition to being a client on OPC where we can talk to anybody else's third-party OPC server, we can act as an OPC DA server as well and have anybody else's client come in and grab tag information, tag values directly from us. We can communicate to databases, and then we also have a driver toolkit and a tag database toolkit if you want to write your own interface to this information. One of the key points, and the reason I bring up this slide, is that with InduSoft Web Studio and the tags, the core of this, we can function as a database, or not a database, but a gateway, a communications gateway from any of these devices to any of these other devices. So for example, if you wanted to get information from an Omron PLC into a database, you can use InduSoft Web Studio to do that, or from OPC into a PLC, or you can even do this from one brand of PLC to another brand of PLC. So we let you do that and encourage that. Another key point that might be made here is because InduSoft has been around for so long, we still have a lot of the serial-based drivers that have been in the product for years and years. And for example, maybe you had a temperature controller that was only serial-based and you wanted to get that on a network or collect data to a database. Well, that in the past wasn't doable. Now with InduSoft Web Studio, you can get that information in via one of our serial-based drivers and send that to a database and get trend information or alarm information from those types of devices where that was never possible before. So let's talk a bit about our drivers and driver worksheets. There are over 240 built-in drivers, and there's no additional charge for those. The drivers that we have built into the product communicate directly with PLCs. Now, the Omron driver is a little bit of a special case, and that's only available and licensed through Omron and their distributors. But I want to talk a bit about, because we have these drivers, OPC is not required. Even though we work quite well with the OPC Foundation, we attend their interoperability workshops, and I've presented several times at their technical seminars. it's kind of an option. We highly encourage you to use our built-in drivers and then use OPC only if it's needed for your particular application. Our built-in drivers tend to be more efficient that way and go directly to PLCs. You can check online on our website for a list of the latest drivers. I highly encourage you to do that before you start any project. It's always a good idea. And we'll talk a little bit about main versus standard driver worksheets. And I know Jay is going to cover a little bit of this in his presentation, but the main driver worksheet has a header, or the top part of this, that looks like this, and the bottom part is actually where you would tie the tag name into the PLC I/O address. And let me pull up a real one of these. Here's InduSoft Web Studio. I'm going to go in here. I've already added a Modbus TCP driver in here, and I'm going to look at the main driver sheet. Here's that header part that was just on the slide. And here you can see the tag name, the station, which will be the IP address typically of the PLC, or node number and port number, and then the I/O point within that PLC that you want to talk to. So this is kind of the glue, is where the tag name within InduSoft Web Studio gets tied to the real-world I/O address in the PLC. And because of this, it's a really nice feature that we have. It's an abstraction layer, if you will, where elsewhere in InduSoft Web Studio, for example, let's say a bar graph. If you put a tag name in a bar graph and tie it to an address in the PLC via this worksheet, if you change the I/O address or even the driver communicating with a different PLC, different brand altogether, you would disable or remove this driver, re-enable the other driver, and you wouldn't have to go through all the bar graphs or all the objects within your entire application, because this is the, again, kind of the glue that makes the magic happen here. The point that I wanted to make out is there's two different types of driver sheets. There's the main driver sheet, which you can put any type of address in, and it figures out the optimization and the communications for you. The standard driver sheets, I'm going to insert one here, not only do they have those same 4 status fields here, but they also have triggering mechanisms of when you want that worksheet to communicate with the PLC or controller. And in this way, you have a lot more flexibility over it, and you can control when you want it to read and write. It's not just faster. Believe it or not, some customers want to go slower. For example, they may have a leased line or an expensive connection to maybe a satellite or a radio modem, where maybe they only want to communicate once a day or every hour or something. You can set that up in here and then burst communications and then shut off your radio and have everything go to sleep, and save battery power, let's say, or costly connections as well. Back to the presentation for a second here. The status fields, I highly encourage you to put tags in there and monitor those. We'll talk about that in the troubleshooting section. And what's really the difference between these two? Really in the main driver sheet, and this chart is covered in the training video that we have, one of the training videos for drivers. Those are available for free if you didn't know that on our website. You can take basically our 5-day full training class online as videos free of charge. You don't even have to register. So this chart is covered in the training video, and just briefly here, the main differences, or a couple differences between the main driver sheet and the standard driver sheet, is the main driver sheet is triggered based on a tag called blink slow, and that is roughly 600 milliseconds as an update rate. And you can change that. It's just by default it's blink slow, but it does affect communication throughout your entire project, or main driver sheet anyway. And the standard driver sheet, you have, as I showed a minute ago, separate triggers for reading and writing, so you get full control over that. And the other difference is with the main driver sheet, you can put any type of address from the PLC in the worksheet, in the main driver sheet, but only one type per each standard driver sheet is allowed for the standard driver sheet. So if you have, for example, a holding register or an integer type register, you would put that in one standard driver sheet, and if you had outputs, let's say, or inputs, you would put those in their own individual driver sheets. So we're not going to go into too much depth on this. This is a little bit of the basics, and if you need more, you can look at those training videos. Another option that we have is what's called tag integration, and tag integration allows you to directly pull in tags from third-party control applications, let's say an export of ladder logic that might export the tag database from the PLC or the I/O points. And then today we only have a few of these, but we're expanding these and plan on expanding these. Today it's a TwinCat, Codesys, the Control Logics are Ars Logix 5000 from Allen Bradley, PLC 5 and Slick, as well as Automation Direct for the Koyo series and PAC 3000, and we even have now a Schneider Unity Modbus in there. And that's basically you pick from the list that is imported, and only the tags that you pick from are the ones that are brought into your applications. The one that you don't choose don't consume tags. Talk briefly about OPC. Again, we do have over 240 built-in drivers, but they're not required. We've been an OPC Foundation member for a long time, and we support OPC DA, UA, .NET, and XML as clients. And not only as clients, but we do have a DA server as well, so you can get the information out of the tags from that. And just a side note, we were the first HMI and SCADA package to be certified in the OPC Foundation Lab for OPC UA. And we also have OPC UA not only on the PC, but on Windows CE as well. So, brief note about troubleshooting, a couple things here. It's suggested that you use the output window or log win within InduSoft Web Studio. And where you'll find that, of course I turned mine off right before the presentation, is down here at the bottom. The output window will let you turn on settings. I've right-clicked in that, settings, and I would suggest if you're doing troubleshooting with communications that you use field read and write commands. That'll show you the addressing that you're trying to read and write from. The protocol analyzer is another way you can get down to the bit or byte level and see what's communicating to the PLC. And I also suggest that you turn on the date and time so you can see the proper sequence that's coming in and out. So that's a really good troubleshooting tool. Not only is it built into the development environment, but you can get at this remotely. So here you can get at LogWin for remote management, and also you can run it on the runtime as well. Another tool that we have is, when you configure the address, it's not uncommon to not be able to get to the PLC on the network, so try pinging it. It's also a possibility to have the wrong port number set up. And as Jay will point out, in some drivers you have to choose the PLC family type because it's a variation of the protocol and how it communicates with the PLC. So it's not just an Omron, it is in other PLC drivers as well. Check the I/O address, make sure the field is formatted, and the status fields. Again, I highly recommend when you're communicating with a PLC that you monitor these status fields and watch to make sure that they're typically, not always, but typically 0 value. If you put a tag in here and the communications is good, you'll get a 0. And if it's not good, you'll get some kind of error code, and you can look that error code up in the manual and see what's going on there and help you troubleshoot that. We do also have a way that you can get at what's called virtual read groups, and this is covered in the training class. But if you have the main driver sheet running, you can go down to your taskbar and right-click, and down in here you'll see the driver. You can right-click on the driver, and it will show you how it's blocked up the communications to optimize communications to the PLC. And let's see, one quick note, and this is covered in one of our tech notes, is be aware of the increase priority checkbox. If you so choose or you think it's a good idea to use in the standard driver sheets this increase priority checkbox to make everything faster, well, what you'll end up doing is maybe making everything faster, but it's so fast that it tries to fill up the queue and you don't get things executing the way that you want. So just be careful of that. And again, there's a tech note covering that as well. So be aware also that we have not only the training videos, but we've done numerous webinars covering drivers and communications. We have a couple, I believe, driver webinars. We have OPC webinars. There's at least 2 training videos on our website, and we also have driver runtime technical note, and we do from time to time post some really good blog articles that are technical in nature. Our blog is not only salesy in nature, it's a lot of technical content as well. So with that, I'm going to go ahead and hand it over to Jay.
Well, Scott, thank you for giving Omron this opportunity to present what I think is going to be a very educational presentation on configuring Omron SYSMAC Gateway and specifically configuring it for use with InduSoft Web Studio. We're going to dive right into this presentation. Let's talk for a moment about what we're going to discuss. The topics that we're going to cover today include what is SYSMAC Gateway, why our customers use SYSMAC Gateway with InduSoft Web Studio, how we package and deploy SYSMAC Gateway with InduSoft Web Studio. A lot of questions that we get revolve around the licensing and the deployment. And then we're going to jump right into configuring Omron FINS networks, configuring the FINS protocol within SYSMAC Gateway, connecting Web Studio to Omron PLCs by the FINS protocol, and then really those same three topics for Ethernet IP, the configuration of SYSMAC Gateway, and then communicating to PLCs and machine automation controllers. So let's talk about what SYSMAC Gateway is. SYSMAC Gateway is InduSoft's middleware software package, and it was specifically designed for exactly what we're using it for with InduSoft Web Studio. It literally is a gateway into the world of SYSMAC, and SYSMAC is kind of an Omron branding of products. It optimizes the communications between applications like InduSoft Web Studio and the Omron hardware. And it does support both FINS and Ethernet IP, which is a SIP protocol. And for anybody that's not familiar with FINS, FINS is an acronym for an Omron protocol. It's Factory Intelligent Network Services. It's been around since the late 1990s, and we deploy it across a wide variety of networks, including Ethernet, some of our proprietary networks like Controller Link, SYSMAC Link, SYSMAC Net, DeviceNet. We've got serial implementations. So it's really an all-encompassing Omron protocol. Let's talk licensing for a second. How is SYSMAC Gateway licensed for use with InduSoft Web Studio? So any development or runtime package of InduSoft Web Studio that is purchased through an Omron distributor, and that's kind of the key there. This needs to be purchased through an Omron distributor, includes in the box that you get not only a disk with InduSoft Web Studio, but a disk with SYSMAC Gateway. So both products come in the same box. The SYSMAC Gateway product does not have to be purchased separately, but it does have to be purchased through Omron, the InduSoft Web Studio product. And when you're looking at the Omron nomenclatures for part numbers, these are the OMSGY part numbers. That's the prefix for Omron SYSMAC Gateway, and that's the InduSoft product. So what's different when you purchase through Omron? When you're purchasing InduSoft Web Studio through Omron, you get this, what we call the FINS or the Omron driver enabled. And if you look on the left there on the hard key settings, you see it says FINS. That tells you that this FINS or Omron driver is enabled in your license, and that you're authorized to use this Omron driver. And the Omron driver specifically is the hook into SYSMAC Gateway as a software package. So why do our customers use SYSMAC Gateway, and why is this such a great feature integrated with Web Studio? SYSMAC Gateway allows access to all of Omron's industrial networks, and it's done through a single driver within InduSoft Web Studio. So if you look at the FINS list on the left, through SYSMAC Gateway, we can access the two different varieties of FINS Ethernet. We can access Controller Link, SYSMAC Link, our Toolbus network, which is a serial network, CV Mode Host Link, which is another serial network, and DeviceNet and some other Omron networks. Through that same driver in Web Studio, we can also access Ethernet IP and USB to the CJ2 family, both of which are SIP protocols. So we package all that up and deploy it within one InduSoft Web Studio driver. If InduSoft were to develop a native driver for each of these, you'd have a whole host of native drivers, and InduSoft would have to maintain and upgrade, all the different drivers. This allows InduSoft to just simply keep one driver, and it lets Omron, as the vendor, maintain and upgrade all of our networks in the background. let's talk about hardware platforms that are supported. So we've got some legacy platforms, the CV series large rack PLC, as well as all of our current generation. And when I say current generation, basically anything created in the last 10 or 12 years. So starting at our lowest CP1E PLC and moving all the way up through our flagship machine automation controllers, the NJ301 and NJ501 series, these are all covered under the SYSMAC Gateway platform. A question that I get asked a lot is what is the difference between the OMETH driver, which is a native InduSoft driver, and this Omron driver using SYSMAC Gateway? It's a great question. The OMETH driver is somewhat of a limited implementation. It's a subset of all of our networks, of all of our protocols, and all of our PLCs. It was around before the Omron driver, so it's a little bit of a legacy driver. And if you kind of look at some of the differences, the Omron driver supports all of our networks. It supports communication both by address and by tag name. It does support all of our processors. It's got some really excellent network testing and diagnostic tools. We're going to dive into that a little bit later. When we address addresses on a driver worksheet in the Omron driver, it's what I call a direct address. So if you look down on the left in the InduSoft driver worksheet, I've got the tag name and then the address. And here I'm accessing data memory, which is indicated in the header field, 20,005. Now 20,005 is a direct reference. In the OMETH driver, in the header field, you put the starting address of the driver worksheet, and then you offset from that on the individual line. So if you wanted to access 20,005, the header would be data memory 20,000 with an offset of 5 on the individual line. It gets a little bit confusing when you've got large projects with a lot of different memory areas, so the Omron driver just lets you hit it directly. We also do support in the Omron driver multi-layer FINS routing, so you can maybe come out your InduSoft workstation PC on Ethernet, hop across an Omron PLC acting as a network bridge, get to controller link or SYSMAC link or a different Omron network. We also support custom FINS commands. So every once in a while, we'll have a customer that'll want to do something like put a PLC in program mode, or send a certain command to reset an error or something out of the norm. Because we've built support for any FINS command you want to send in the Omron driver, it's a very easy implementation. It's something the OMETH driver can't do. A couple other things we support. We support the redundant Ethernet communications on our CS1D platform. And this is a continuously evolving driver in the Omron driver, whereas the OMETH driver is pretty much at a static point in its life and probably is not going to have any enhancements. So that's just a quick comparison of the two drivers. As part of this webinar, when InduSoft sent you the invitation to attend, you should have received also a link to download the Omron Quickstart guide for installing SYSMAC Gateway. So in this webinar, we're not going to go through and talk about how to install SYSMAC Gateway, but this Quickstart guide does discuss that. Okay, so let's jump into the meat of this presentation. And we're going to start out looking at FINS. We're going to talk first about setting up Omron networks. And this is kind of the magic and where you have to do the work up front to prepare. And once you do this preparation, communications are actually very easy. So when we talk to a PLC by FINS, there are 3 pieces of information that we specify to identify a unique device. We talk about a FINS network number, a FINS node number, and a FINS unit number. And when we talk about communications for FINS in general, you're going to hear me say net.node.unit. And when you're entering this information in our network testing tool or within Web Studio, you're going to enter it as a network number dot node number dot a unit number. Let's kind of peel this apart. If we look at the FINS network and you look at a plant floor or manufacturing cell, you may have multiple layers of Omron networks all connected together. And the point of assigning a FINS network number is to uniquely identify each network. So in this network diagram, DeviceNet has been assigned network 1, Ethernet has been assigned network 2, and controller link has been assigned network 3. And we're going to talk about how we do that. The software tool that we use to do this is called CX Integrator, and what we're using CX Integrator to set up are what we call FINS routing tables. And a FINS routing table has two purposes. In blue on the left is what we call the local routing table. And what this does is, if you look at a given PLC, and this routing table is written for a given PLC, it assigns a network number to a specific unit number. And the unit number is a hardware set rotary switch, typically, on a PLC module. In some cases, it is a software setting. But it makes the link between the unit number and the network number. And in this example, I have unit number 0, which is a controller link card, and I've assigned that to be net 1. Unit number 1, which is a device net card, is net 5. Unit 2, which is Ethernet, is network 12. And then unit 252, which is the built-in serial port on a CS1, I've assigned that to be network 111. And simply by making all those entries in the local table is how we do that. On the right is the remote table, and what this configures is how this PLC would communicate to a network that it's not physically part of, and I'll show you in the next diagram or next slide what that looks like. The other resource I'd like to point out is if you search YouTube, there is a video, and if you search for creating an Omron FINS routing table, it will take you to that video, and it goes soup to nuts, building and configuring and downloading an Omron FINS routing table. It's normally about a half hour or an hour discussion by itself, so we're not going to do a deep dive into routing tables in this webinar. Let's talk about FINS node numbers. So when we look at a network, every device on a network has a node number, usually a hardware rotary switch. And give you some ideas of where these can be found. If you're looking at a controller link card, that is a 2-digit rotary switch setting, an Ethernet card like an EIP21 or an ETN21, again, hardware set. If you're using one of our serial to Ethernet gateways like a CP1W CIF41, that is a software set by a web interface node number. CP1LE, our micro PLC with built-in Ethernet, again a software setting. And the CJ processors and cards are, again, hardware settings. So that's how you set the node number. And the unit number. The unit number in the FINS protocol talks about which device on a PLC backplane you're communicating to. The number that you want to remember for Web Studio is always use unit number 0. That means the CPU. If you're using a number other than 0, you're talking to something else on the backplane. And the only reason you would talk specifically to something else on the backplane would be to read or write its configuration. So CX Programmer in the background would write to a different unit number to download the setting to an Ethernet card to change the IP address or the subnet mask or something like that. And a quick analogy I'd like to make before we move on to the FINS console. If you think about net.node.unit, the way I often explain that is if you're trying to deliver a letter to someone in a house and they're in a particular room, I usually describe the network as the street that the house is located on, the node number as the house number, and the unit number as the room in the house where the person is located. So you can think of net.node.unit as street.housenumber.room. It's kind of a quick little analogy. We're going to take a look now at the FINS configuration within SYSMAC Gateway. And that can be accessed by going to the Start menu, the FINS Gateway group, and launching the FINS Gateway setting. And what you'll see in the control panel, first off, is a list of Windows services. So the CPU unit, the ETN unit, which is the Ethernet unit, the serial unit, those are truly Windows services. Each service can be started or stopped manually, or configured to auto start, and it will start as a Windows service. So when you choose a service like the Ethernet unit, you can choose whether it's a manual startup or an auto startup. And for a runtime deployment of InduSoft Web Studio using the FINS protocol, you would want to set that as an auto start. That guarantees that FINS Gateway will start up as a service, and then when InduSoft launches, typically from the startup group, the background communications of SYSMAC Gateway will already be running. Let's talk now about configuring a specific service. So we'll look at the Ethernet service, for example, and we'll go through and configure that. And the way that we do that is we click on Network and Units under the Network group over on the left, and then on the right, you'll click on the local network. In this particular case, it's the Ethernet network. And we're going to configure a couple of things in the Ethernet service. On the Network tab, the first thing that you want to configure is the network number. So this is assigning the FINS network number to the Ethernet service within SYSMAC Gateway. This number would have to match whatever you've configured in the FINS routing table in your PLCs. One shortcut that you can take, if you have a network in which you will never ever be running multiple services in SYSMAC Gateway, and you will never ever try to bridge across a PLC and access a remote Omron network, you can leave this network number set to 0. You don't have to put a routing table in your PLC, and you can use network 0 within InduSoft Web Studio. It's not what Omron recommends, but for quick testing and setup of a very simple, very small network, it's an efficient way to get communications up and running. Over on the Communication Unit Setting tab, you can configure things like the UDP port number of the computer and of your field devices. You can choose which Ethernet card in your PC you are using, and then configure things like what we call FINS to IP conversion, which you would typically want to leave it automatic, and also the node number in FINS of the computer, and again, you would want to leave that for generate auto from the last octet of the PC's IP address. Those are all the default values. Once that's all done, all you have to do is hit OK, and then the SYSMAC Gateway will prompt you to restart the Ethernet service, and you can say yes. It'll automatically start back up again. And now you're ready to move into testing. So that was a pretty quick setup. Once it's set up, you're going to go in and use this exceptionally powerful testing tool in SYSMAC Gateway for the FINS protocol. This is called the FINS Network Tester. Think of this as like a ping for Omron networks. It lets you send any FINS command to any FINS device on any FINS network. It's an exceptionally powerful but easy to use tool. From within the FINS Gateway console, you would click this little yellow down arrow, and it launches the FINS Network Tester. In the FINS Network Tester, you specify the peer address, which is the device that you want to talk to, and you specify that by net.node.unit, just like we talked about when we talked about setting up FINS networking. You also choose your FINS command. The FINS 0501 command, which is the default command, is a model read, and it's just a quick way to read out what the device is, verify that you're talking to the right device. You can also specify a number of iterations. The default number of iterations is 1. You can increase that number, or you can put it into continuous. Continuous would just literally continuously send the message out as fast as possible, and it gives you a good long-term integrity test of your network. So once you've configured your FINS command, you hit send, and what you get back is a couple of really good pieces of information. So you get back the data, and in this case I was communicating with the CJ1H CPU66. I get back the time it took to get that response, and if you're doing multiple iterations, it gives you the average, the min, and the max. And it also tells you whether the result was successful or unsuccessful. So a lot of really good information right in this one window. Once you have your network communications working from the network tester, it's a very simple migration to now move into Web Studio. So in Web Studio, we're going to go add a driver, and the driver that we're going to add is the Omron driver. And add just like any other driver within Web Studio, just click on it and hit the select button. Once you've inserted the Omron driver, there's a couple of things you can do. By right-clicking on the Omron driver, you can launch the help PDF file. You can also directly launch the FINS network tester that we just looked at. So in Web Studio, we've built a hook into that testing tool directly. Let's talk about configuring the Omron driver. There's a couple of important configuration points. The first thing you want to do is right-click on the Omron driver and go into Settings. And you will always want to set Ignore Non-Fatal PLC Errors to a value of 1. What this allows Web Studio to do is receive a response back from the Omron PLCs that contains some sort of a non-fatal error, maybe a low battery alarm, maybe an I/O table mismatch, something that's still allowing the PLC to run, but probably has the error/alarm light flashing. And if you don't do that, if this were a value of 0, any incoming data packets into Web Studio that had a non-zero error code, meaning there was a low battery or something like that, InduSoft would consider bad quality, mark the quality as bad, and treat the data as incorrect and put question marks on your screen. So if you want to allow good communications even in non-fatal, non-critical errors, set that value to a 1. The second thing we can do is we can set the block size. And the block size has to do with the main driver worksheet and how InduSoft Web Studio optimizes communications making virtual read groups. And I know that there are some additional InduSoft videos on the topic of driver worksheets. So if you want to know the details of how all that background works, you can do some research and watch one of the videos. But the way you'd want to set this is take a look at what Omron network you were using and choose the appropriate maximum block size based on the block size of the protocol itself. So for example, FINS Ethernet has a maximum block size of 998 words. So if you were using FINS Ethernet, you would put 998 in the maximum block size. Controller link would be the same, toolbus would be 501 words, etc. So choosing from the chart, you can fill in the maximum block size. If you go into the advanced settings for the driver, you can configure the timeout. A lot of times 1,000 milliseconds is a fine default. What you will want to change is simultaneous requests. If you have a configuration with multiple PLCs, let's say you have 4 PLCs, you would want to set simultaneous requests to 4. What this does is it enables Web Studio to spawn in the background a different communication thread, if you will, to each PLC. So it's not a round robin of all of the PLCs as far as reading data. You've got 4 asynchronous communication pathways open, 1 to each of your PLCs. So it really optimizes and makes your communications very efficient. I know Scott talked in the beginning of the webinar about driver worksheets, so I'm not going to go into great detail about the differences, but we obviously do support both the main and the standard driver worksheet. My take on this and my personal view, I tend to use standard driver worksheets more than the main driver worksheet. It gives you flexibility and control over when reading and writing is enabled. I often do triggering as well. So I'm just kind of showing you a couple of snapshots of what the two look like. And we're going to dive into how you configure both of them within the Omron driver. So the main driver worksheet is configured, and I've left the status field blank because that's a generic feature of Web Studio, and I'm focusing on the Omron specifics. You put the InduSoft Web Studio tag name under the tag name. In the station field, you put net.node.unit, just like we saw in the network tester. And then you append that with a colon and a PLC type. So if you're using a CV series PLC, you put colon CV. If it's a CS1 series, you put a colon CS. And if it's any of the other listed PLCs, a CJ1, CJ2, CP1L, or CP1H, or E, or even the NJ, you put a colon CJ. Under the IO address field, you put the data area, colon, the data type. And there's a slide, one more further on, that I'll list out the memory areas and the data types. The standard driver worksheet now moves the net.node.unit colon PLC type up into the station field. So the standard driver worksheet is reading entirely from one PLC. And the memory area also applies to the entire worksheet. So this entire driver worksheet would be for the data memory area. Once you've done that, you put the InduSoft Web Studio tag name and the PLC address and data type. The data areas that are supported are all of the ones listed, which are pretty much all of the internal memory areas in our PLCs. The auxiliary area, the core I/O, the data memory area, our extended data memory area, the holding registers, timers, counters, the work area, all those different areas. So that would be the letter or group of letters that you put, followed by a colon and the data type. And what I'm showing here is a list of internal CX programmer data types on the left, and on the right, the data type that you would put in the driver worksheet. So if you were using a long integer in CX Programmer, maybe as data memory 50, you would put D50 colon LINT to tell Web Studio that it's a long integer. An important concept on standard driver worksheets is what I call the span of the worksheet. On any InduSoft standard driver worksheet, I believe for any driver, what InduSoft Web Studio is doing in the background is making one read command to read the entire worksheet. And you can't exceed the size that the protocol supports. So back to our maximum block sizes, for example, FINS Ethernet, the maximum span that I could have on a standard driver worksheet would be 998 words. In the example that I show, I have 701 words total. The lowest address within the data memory area is 0. The highest address on the worksheet is 700. That has 701 words as the span and is smaller than the block size. If you exceed the block size, the driver worksheet fails to read, and you get an error code in your status words, as Scott was pointing out to you earlier. Okay, I'm going to branch out into Web Studio, and we'll do a quick live demonstration of FINS. So I have a simple application with 5 different PLCs in it, and the first one that we'll take a look at is a CP1LE, and if I look at the driver worksheet for the CP1LE, it's very simple, net1.node68.unit0. It is a CJ series, as we discussed before. I am reading and writing from the core I/O area. I have a couple of bits. I have an increased tank level button that you'll see in a second, a decreased tank level button, and then feedback that is the tank level. And if I go to the running application, and we go to the tank level, pressing and holding the fill button is increasing tank level, pressing and holding the drain is decreasing the tank level. So very simple tank filling application, but this is just an example of how you would fill out the driver worksheet. another simple application, a prison application, group release button to go ahead and on a timed release, open particular cell doors during maybe a panic situation or an evacuation where they'd want to do a sequential release. And again, this is net1 node 25 unit 0 colon CS. This is a CS series PLC. And again, you can see how the driver worksheet is filled out. Question that often comes up is, let's say I want a gateway across to a different FINS network. Maybe my computer is on network 1, which is Ethernet, but I also have a controller link network, which in this diagram is network number 2. How do I access that? So within the FINS Gateway settings console, we click on Ethernet and then we click Add Remote. And this is adding a remote network to FINS or SYSMAC Gateway and explaining how to access it. So what you'll see is I've specified that the remote network is network 2. That corresponds to this network. To get to that, I come out the PC on network number 1, and I bridge across on this node number 2. So I'm really just pointing to the first hop along the way to get us to this remote network. Once you hit OK, what you'll see in the FINS console is that there is this destination network 2 as a remote network through this gateway node. So that's how you add remote support of networks that the InduSoft Web Studio PC is not physically part of. We can bridge up to 7 network layers. So you can have 7 different gateway PLCs between InduSoft Web Studio and the device that you're actually talking to. That's a lot of network hops. One thing that's important to understand in Omron PLCs when we're talking about SCADA applications is how we can affect the communication time. One thing that we can do to dramatically improve the response of Omron PLCs, especially in situations where you have a large number of InduSoft Web Studio applications or maybe Omron NS or NB HMIs or even other PLCs communicating to a PLC, is we can open up a window of time on a PLC to give more time to service communications. The default setting on our PLCs is 4% of the scan time of the PLC. So if you have a 2 millisecond typical scan time of a PLC, that's not a lot of time allocated for servicing communications. What we can do is manually specify a maximum amount of time. And that's done through our peripheral servicing. And the way you access that in CX Programmer is you go into Settings, you uncheck Set Time to All Events as the default, and you manually put in a value. This is in increments of 0.1 millisecond, so a value of 50 is 5.0 milliseconds. That will extend your scan time possibly by up to 5 milliseconds, but in a lot of applications, it will dramatically reduce the response time of the PLC, especially when you have a lot of InduSoft Web Studio clients or HMIs or other PLCs all talking to a single device. A little bit of troubleshooting. So Scott mentioned earlier things like doing a ping, putting tags in the status fields for your driver worksheets. The FINS Gateway Network Tester that's built into SYSMAC Gateway is another great troubleshooting tool. If Web Studio can't communicate, I immediately drop back and look at the network tester and figure out if I can communicate and troubleshoot from there. Another question that we run into is, what is an error code 126? If you try to add a standard driver worksheet or run an application and you get one of these 2 windows, what that means is you're using the Omron driver, but you don't have SYSMAC Gateway installed. SYSMAC Gateway must be on the PC since InduSoft Web Studio is communicating through SYSMAC Gateway. So that's what those 2 error windows are. Now we're going to branch over and look at Ethernet IP as a protocol and how SYSMAC Gateway addresses Ethernet IP. Again, we're going to take a step back and look at the configuration in the PLC. And we're going to take a look first at a CJ2M or a CJ2H PLC, which do support communications by Ethernet IP by tag name. When you are making a tag or a variable in CX Programmer, give it a name, give it a data type. You can either give it a fixed address, or these PLCs do support automatic addressing. The key is it has to be defined as a network variable, so you have to put a check mark in network variable. It can actually be publication, input, or output. It doesn't matter as long as it is a network variable. That puts it in what we call our internal tags database and exposes the tag to Ethernet IP. We also support user-defined data types, or what we call structures. So if you have a structure in your CJ2M or CJ2H PLC, we can communicate to the different members of the structure from Web Studio. Again, it does have to be a network variable. If you are using an NJ machine automation controller, same concept. The tags have to be of a network type called publish only. If it is a physical I/O device, it could also be input or output, but if it's an HMI tag only, it would be set as publish only. That makes the tag accessible by Ethernet IP. Let's take a look now at setting up the SYSMAC Gateway console, which is the Ethernet IP or SIP side of the product. We access this by Start Omron SYSMAC Gateway console. And what you'll see is, again, kind of a list of Windows services. We're going to, again, configure Ethernet. So I'm going to choose the Ethernet port and click Properties. And in the Properties, we're going to set that this Ethernet port will automatically open when the SYSMAC Gateway SIP service is started. You can choose which network card you are using, and in case you have multiple IPs for that card, you can choose which IP you are using. Just like we saw in the FINS Gateway console, you can choose whether the SIP part of SYSMAC Gateway is an auto start service or a manual start. And again, for a runtime environment, you would want to set this for auto startup. Just like we saw in the FINS part, there's a very powerful testing tool for SIP. And if you're in the SYSMAC Gateway console and you go to the control panel, there's a communication test tool. Simply put in the IP address for the CJ2 or the NJ that you're going to communicate with. And again, the get attribute all of the identity object, that's a model read. That's the default command. You can put in there other Ethernet IP commands if you're familiar with Ethernet IP. Then you can hit the send button. Again, what you get back is an OK or no good result, a response time, and then the data that you asked for. And normally, again, we're using this like a ping tool to make sure that we can talk to the device through SYSMAC Gateway before we move into InduSoft Web Studio. Now let's look at how to configure the Ethernet IP driver worksheets, or the driver worksheets for Ethernet IP in Web Studio. Just like we saw before, we're going to use the Omron driver. It's the exact same driver we used for FINS, so there's no distinction between driver and protocol. So we add the driver, and just like we did before, we add the Omron driver. On the main driver worksheet, you put the InduSoft Web Studio tag name. You put the IP address of the controller, so your CJ2 or your NJ, :2, :NJ or :CJ2. The 2 tells Web Studio that you're using port number 2, as you can see down the bottom right-hand side of your screen, which is the Ethernet service within SYSMAC Gateway for Ethernet IP. If you were using USB to go to a CJ2, you theoretically could put 3 in there, and 99% of the time we're doing this by Ethernet. On the I/O address column, you put tag : the InduSoft tag name. So it's just simply tag and then the PLC tag name. If you are using a standard driver worksheet, you fill that out in the station field with the IP address of the device, :2, :NJ or CJ2, depending on what processor you were talking about. The header is tag, and you simply fill out on the left the InduSoft Web Studio tag name, and on the right the associated PLC or machine automation controller, in the case of the NJ, tag name. So now I'm going to, again, branch out, go into Web Studio for a moment, and have a couple of different PLCs that we're communicating with. So if I look first at a CJ2 conveyor application that I did, simple conveyor dropping things into a box, and in this particular case, I did use a user-defined data type in the PLC, and I did use a class within InduSoft. So I have a tag, which is a class tag, CJ2 conveyor section 1, dot start command is the InduSoft tag. And in the PLC, I've got conveyor section 1, dot start command. And I've listed out each class member from the InduSoft tag and each address, and each tag and member within the PLC. And if we go to the running environment, what you see, we can start and stop the conveyor. And again, we're doing all this by Ethernet IP. If we run the conveyor, we can run the conveyor at slow speed, dropping Christmas packages into boxes to be shipped, hopefully, to our relatives. I've also got an NJ tank level application, just like for the other PLCs. This is communicating by Ethernet IP. Open the valve, you can fill the tank. Close the valve, you can drain the tank. And again, this is by Ethernet IP with the station of 192.168.1.44, :2, :NJ, with a header of tag, and then simply the InduSoft Web Studio tag names and the NJ tag names. So very, very simple and very straightforward configuration. We branch back to the presentation. That is the conclusion of the presentation. A little bit of contact information for Omron, our corporate address, our telephone number for contacting Omron technical support. If you are in a part of the world outside North America, from the Omron North American website, you can click in the box that I've got circled in red, choose your area of the globe, and it will direct you to your local Omron office wherever you're located. So, Scott, at this point, I'd like to open it up, turn it back over to you.
Jay, thank you very, very much. I think I learned even more than I did in this morning's. I caught more information than I did in this morning's webinar. So
okay, and
thank you very much.
Hopefully our attendees feel the same way. So that's great. Great feedback.
Yeah. So let's see. Right now, I just as I was switching things over, I didn't see any questions coming in yet. Let's see, trying to get things going here. Share my desktop again. Oh, it looks like we do have a couple of questions. One question is, could you address a whole class in one line, or is it only possible to address individual members?
So that's a great question, and the way that the product is structured right now, each individual member of a class and a user-defined data type does have to be listed individually. That may be changing in the future, I'm not sure, but currently it is a one-for-one allocation. If the user is asking for a SYSMAC NJ product, one of the things that I've developed as an Omron engineering tool, I have an Excel worksheet where you can copy and paste the tags out of our SYSMAC Studio software product, paste them into Excel, click a button, and it massages and builds a driver worksheet that you can then copy and paste directly into InduSoft Web Studio. So that's something that we can make available.
Great, thanks. Let's see, another question that came in. It says, do I have to install a SYSMAC Gateway on the runtime machine or only on the engineering station? And will it be transferred to the runtime machine while downloading the IWS project to it?
Okay, so that's another great question. And just like you have to install InduSoft Web Studio on both a development machine and a runtime machine, the same does apply to SYSMAC Gateway. That's installed on the runtime machine because it is a full-blown communications gateway.
And then Mike just chimed in and said, but not thin client. Does that make sense?
Well, sure. If you are running a thin client application connecting into a computer running the full-blown installation of Web Studio, just running a web thin client or a Studio Mobile Access or something like that, that PC would not require SYSMAC Gateway. It's just whatever PC is actually communicating with the hardware.
Okay. Next question that came in is, what is SYSMAC Compolet? I've seen it mentioned but not explained.
Great question. So there's technically two products that I'm lumping together and calling SYSMAC Gateway. SYSMAC Gateway is the runtime engine, and CX Compolet is a .NET library and .NET class that InduSoft Web Studio also uses for communication. So what is actually deployed is CX Compolet with SYSMAC Gateway. I am referring generically to the product as SYSMAC Gateway.
Okay. And let's see, Mike chimed in again and said, please remind them about the part numbers, the OMSGY part numbers, that it contains both the CX Compolet with the SYSMAC Gateway.
Right. So any of those OMSGY part numbers ordered from Omron, which is the bundling of InduSoft Web Studio and what I'm calling CX Compolet really is, I'm calling SYSMAC Gateway. It does include CX Compolet and SYSMAC Gateway, which is installed as one product.
Okay. And another question, we had this one come up in the morning. I'll leave it to you to answer, Jay, which is, can FINS Gateway be installed for a project on an embedded device or HMI with Windows Embedded Standard 7?
So with a Windows embedded operating system, there are certain dependencies that need to be included when you're creating the build for that computer. And as long as you've got all the dependencies, such as an Ethernet card and the Ethernet driver and possibly some Internet Explorer dependencies, as long as the groundwork is laid, then yes, you can install SYSMAC Gateway on that embedded PC.
Okay. And somebody asked, is SYSMAC Gateway an extra cost or an extra licensing?
When it's purchased through Omron, it is included and deployed as part of the product. So it's not something that has to be purchased separately, or there's no license that has to be separately purchased. When you buy it through Omron, everything that you need is included.
Okay. Continuing on with that, we had another question come on that asked, is InduSoft available through Omron? And if so, what is it included with?
So the InduSoft Web Studio product definitely is available for purchase through Omron, and when it is purchased through Omron, it includes both the SYSMAC Gateway product and InduSoft Web Studio, and it is one part number from Omron for a given license level. So it's not two
Great.
part numbers.
Okay, and kind of related to that, somebody wanted to know, now that InduSoft has been purchased by Invensys and Schneider, what's the relationship with Omron? And I have to say that it's stronger than it's ever been. We have a great relationship. We work real close with the guys at Omron. And Jay, again, thank you very much for doing this. I know our team has worked with Jay for a number of years, and we look at enhancing the Omron driver and continuing this relationship for a long time to come. So, yeah, stronger than ever. Some compliments coming in, thank you. And right now, that looks like all the questions that we have. A lot of questions, a lot of great questions. Another last-minute question that came in was, where can we download this presentation? Those will be made available. The presentations and the recording of this will be made available in a couple of days, and you'll receive an email where you can get those. And if you don't get the email, which you should, because there's a survey attached and you can get a free T-shirt, but if you don't, just look on our website under the webinar section. It'll be posted there and on our YouTube channel as well. So great. And thanks to Jay again. We really appreciate it. Just another quick little logistic thing. If you need to contact InduSoft, you can send us an email at info@indusoft.com, or you can email our other offices around the globe. You can always go onto our website and chat with us, or give us a call. We'd love to hear from you. And please fill out that survey and let us know how we're doing. Let us know what you'd like to see in future webinars, and so we can improve them and get you the information that you need. So with that, Jay, thank you very much, and really appreciate you joining us today.
All right, my pleasure, and again, we certainly appreciate the opportunity, so thank you very much, Scott.
Okay. Thanks, everybody. Have a great day.